Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on set notation. So hopefully by the end of this video, not only will you understand the set notation, you can use it to shade regions of Venn diagrams. So set notation is very important because sets come up in probability all the time. You can't really have probability without sets. We've come across sets before. The sample space is a set of outcomes, but you can also have sets of other objects. You know, the set of all students with blue eyes, the set of all numbers greater than 2. Some sets are infinite, some have finitely many members. So we know some of this notation already from when we did domains. We knew something like this means 2 is an element of the real numbers. So another way to view this is a member of. 2 is a member of the set of real numbers. And we saw that this sort of double R means real numbers. So another set you'd be familiar with is the set of all rational numbers. Remember, that's the set of any numbers that can be written as a fraction with an integer numerator and denominator. Like a third, for example, is an element, is a member of the set of rational numbers. Now, if something's not a member, we can just cross out that little e sign. So, for example, the square root of 2, that is not a rational number. You can't write it as a fraction, an integer divided by another integer. So we could write it like this. We could also write it like this. So root 2 is a set of numbers that are not rational numbers. So this is the set of irrational numbers, because this line up here means not. So let's construct a few finite sets of our own. So I've listed 2 sets here. A, the set of all multiples of 3 that are less than or equal to 20. Remember, these 2 squiggly brackets mean they signify a set. And B is the set of all multiples of 4 less than or equal to 20. So both of these sets are said to be well defined because there's no ambiguity whether or not an element is in either of those sets. We can tell very clearly, is the number 13 in either, both, or neither of those sets. So the set A, which is the set of all multiples of 3 less than or equal to 20, so it would include 3, 6, 9, 12, 15, and 18. And B would be the set containing 4, 8, 12, 16, and it include 20 because it said less than or equal to 20. So this little notation here means the number of elements in A in between these lines. So the number of elements in A, the number of members is just 6. There are 6 numbers, 6 members of this set, and the number of members in set B is 5. So some more notation we need to go through that we've been introduced to in previous years and also previous lessons. So remember, A and B, that little n means and. That includes elements that are in both sets. So here, the set A and B includes the number 12. That's the only number that's in A and also in B. So remember this here, A union B reads A or B. It's all the elements that are in A or in B or both. So it includes all these ones. So this A or B includes any number that's in one or both sets. So note, if I say something like A and B dash, this dash here, means not. So this actually says A and not B. All of the elements that are in A, but also not in B. So that would include 3, 6, 9. It wouldn't include 12 because that is in B, and also 15 and 18. So now we're going to look at showing sets visually on a Venn diagram. So you've probably seen Venn diagrams before. So here we have a rectangle, and inside 2 circles, each circle representing a set. I've called my sets here A and B. So I'm going to first shade in this, which says not A and B. So note, I can use A dash or a line over A. Both of them mean the same. They mean not. So they would mean not A. So in this case, I'm being asked to shade in everything that's not in A and B. Now, so we know this middle region here is the region A and B, because it's the region that contains things that are in A, but also in B. So I need to shade everything that's not in that region. So what I want to do is I want to shade everything in this B circle that's not in the middle, everything in the A circle, and then I want to shade everything outside the circles. So what is unshaded is A and B. I've shaded in everything that's not A and B. So in this next one, I'm going to shade in this region here. So this means not A or not B. So I want to shade everything that's not A, everything that's not B, or is both of those things. So where am I going to shade? So I can shade out here because this is not A, it's also not B. So I can shade out everything here. This is both, not A and not B. I'm going to shade that. Now I can shade this part here because this is not in A. I wanted to shade everything that's not in A, not in B, or both. So similarly, I want to shade this region over here, just this region, because it's not in B. I've shaded everything here that's not in A, not in B, or both. As you can see, these are the same. In fact, these two are exactly the same sets. Now, you've seen Venn diagrams a million times with 2 sets. We can also draw them with 3 sets. So here is a Venn diagram with 3 sets, A, B, and C, 3 overlapping circles there. So what I'm going to do here is I'm going to shade in not A and B or C. So I want to shade everything in this Venn diagram that's not in A and B, is in C, or is in both. So let's start by going through what is in not A and B. Well, similar to what happened here, A and B is this region here. Anything in there is in A and is also in B. So if I want to shade anything that is not in A and B, I shade everything except that middle bit there. So I would shade everything outside of all of the circles. I would also shade everything here. I'm shading in everything except what is in the overlap of A and B. So that would be how I shade in not A and B. Now I also want to include everything that's in C. So here, everything in C should be included. So I need to also shade this part here. Even though it's in A and B, the fact that it is in C means I shade it. I wanted to shade everything that's not in A and B, not in this, or is in this circle. So the only region left is this small region here. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.